welcome to the deep dive. So today, our mission is to kind of extract the hidden brilliance behind this really dense, highly technical spec sheet from HDTVSupply.
Yeah, it is definitely a dense one.
Right. We're looking at a device called the AJA FiDo-2R two-channel receiver. And the goal here is to translate this jargon-heavy product page into, a fascinating look at how massive live broadcasts actually work behind the scenes.
Exactly, because it's completely different from how things work in your living room.
Totally. So to set up why this little box matters to you, think about sending a signal over a standard copper wire, like pushing water through a miles-long pipe.
Oh, sure. Eventually you just lose pressure because of the friction, right?
Exactly. Copper cables suffer from a similar kind of electrical resistance, and that degrades video signals over really long distances.
Which is a huge problem in broadcasting.
Right. But the thing I want to ask you is, why on earth does a broadcaster need to send a video signal 10 kilometers, which is like over 32,000 feet in the first place?
Well, it's mostly because of the sheer massive scale of live events. I mean, if you're shooting a sprawling, multi-stage music festival or, a massive stadium football game, the cameras catching the action are nowhere near the actual broadcast trucks.
Right. Those trucks are usually parked way out in the lot somewhere.
Exactly. So to cover that massive distance without losing the signal to that electrical friction you mentioned, broadcasters use single-mode LC fiber optic cables.
Okay.
They literally send the uncompressed high-definition video as pulses of light.
Just shooting it through a vacuum.
Yeah, pretty much.
Okay. And that is where the FiDo-2R acts as the translator at the end of that run, right? It sits at the broadcast truck, receives those incoming light pulses, and then converts them back into electrical signals.
Specifically into 3G-SDI, yes.
Right. And for anyone outside the industry, SDI is basically the professional, heavy-duty alternative to, like, the HDMI cable you plug into your TV at home.
Yeah. The big difference is that it physically locks into place.
Oh, so a stray cameraman doesn't trip and just accidentally unplug the entire Super Bowl.
Exactly. But that conversion from light back to electricity is crucial for another reason. It actually solves an even bigger engineering problem than just bridging the distance.
Wait, are you talking about the electrical isolation feature that was mentioned in the specs? Because here's where it gets really interesting to me.
I am, yeah. I mean, if you've ever plugged in your home stereo and heard that terrible buzzing hum, you've experienced a ground loop.
Oh, yeah, that is super annoying.
Right, and it happens when different outlets have slight variations in electrical voltage. Now, scale that problem up to a massive stadium drawing power from a dozen different generators.
The electrical interference would just completely ruin the broadcast audio and video.
Yeah, absolutely. It would be unwatchable.
But because fiber optic cables transmit light, they don't carry any electrical current at all. The light just completely ignores all of that electrical interference across the stadium.
Yeah, the electrical isolation is literally built right into the medium itself. It's just an incredibly elegant solution.
It really is.
And in the high-stakes world of live broadcasting, elegance really has to be paired with uncompromising reliability. The spec sheet emphasizes that this unit features completely independent dual channels.
So if, like, a misguided forklift runs over one fiber path, the second channel just keeps the broadcast alive.
Exactly. Plus, it passes through all the complex SDI metadata, and that includes HDR. So the broadcast truck gets the exact same stunning, zero-loss, high dynamic range picture quality that the camera just shot.
Okay, hold on. I need to push back on something here.
Oh, sure.
Because the physical hardware specs seem completely contradictory to me. You're telling me this thing is processing up to 3 gigabits of data per second and surviving stuffed in a cramped server rack at 104 degrees Fahrenheit.
Yeah, 40 Celsius, it gets hot.
Right. But it doesn't have a massive cooling fan, and it only draws 3 watts of power. It weighs half a pound and is barely 4.5 inches long.
It sounds impossible, right?
Yeah. How does a device the size of a smartphone handle a whole stadium's video feed without just melting?
Well, it really comes down to highly specialized engineering. Instead of using a general-purpose processor that wastes a ton of energy and generates heat, this device uses dedicated circuitry.
Oh, so it's optimized purely for that fiber-to-SDI conversion.
Precisely. By drawing only 3 watts, it naturally generates almost zero heat. And that ultra-low power consumption is exactly why it can survive those 104-degree environments.
Without needing a bulky, failure-prone cooling fan. Wow. So it's doing the heavy lifting of a massive infrastructure piece, but literally fits right in the palm of your hand.
Yeah, that really puts the engineering into perspective. So the next time you sit down on your couch to watch a flawless, live stadium broadcast, remember that pristine image isn't just magic.
Right, there's actual hardware doing the work.
Exactly. It's only possible because of tiny unsung heroes like the FiDo-2R just quietly translating miles of light into electrical data behind the scenes.
Which definitely makes you wonder about the future. If we can already send uncompressed, pristine HER video as pulses of light over 10 kilometers with zero signal degradation using a pocket-sized receiver.
It really opens up a lot of possibilities.
Exactly. What happens when this level of lossless long-distance fiber conversion scales down to everyday consumer tech? Will your local hard drives and home gaming consoles even need to exist?
That is a fascinating question.
Or will our entire digital lives simply live miles away, connected instantly by light without a millisecond of lag? It is definitely something for you to mull over.